So in this question here, we've got a random variable x is normally distributed 15, 25. So that means that mu is 15, that's our mean, and our variance is 25. So mu equals 15, variance equals 25. If you know the variance is 25, you know the standard deviation is the square root of this, which is just 5. So with that, we could mark these numbers on our bell curve. So mu is 15, that's going to be the centre, that's the highest point of the bell curve. And then moving across up or minus one standard deviation, will be adding or subtracting 5 accordingly. So we'll have 20, 25, 30, 10, 5, 0, and so on. And these numbers will keep going on. So what we want to find is the probability that x is greater than k. And the answer to that would be 0.6. So we want to find k. That's what we want to find. So that's our goal. Now, if 0.6 as a percentage, that's 60%. So 60% obviously more than 50%, because from the mean, that would be 50%. So we've got somewhere along here. So we want to find this shaded area here all the way across. Now, our inverse normal CD function is what we want to use. That will tell us the probability x is less than some value. Let's call that x. But we want to find the value probably x is greater than k. Now, as the normal distribution is symmetrically distributed, that means if this side would be 0.6, then this side would be 0.4. So if that's 0.6, this is 0.4. So then what we can do is use the probability x is less than x equals 0.4. So then we would use mu equals 15. That would be input on our calculator. We could put standard deviation of 5 in our calculator. And the other bit we need is the area, which would equal 0.4. Now, one good estimation of this is by the empirical rule. So if this here is 50% or 0.5, this bit here, if we go from here, that would be 34%. Now it's definitely going to be less than that, because that would give us just under 16% for this side, but we've got 40%. So we know that k has to be greater than 10. So that's a kind of just a check that to make sure we're getting the right result from our calculator. Now if we type this into our calculators with mu 15, sigma is 5 and area equals 0.4. So we need to set it to make sure it's on the left tail, which is good, that's already on there. Now we need to set the area to 0.4, which we've now got. We need to set the standard deviation to 5, the mean to 15, and that comes to 13.733. Now what we can do, just to check, we could set this to the right tail and then set the area to 0.6. So by the laws of symmetry, we should get the same answer. And there we see that we do 13.733 and so on. 13.73. So therefore our k value, which would be here somewhere, would be 13.73. And that would be the answer to our question. Okay.